Okay, you're welcome back to my channel. So in our last class we talked about power series and we concluded with Maclaurin series and how it was derived. So now we'll be talking about how to use that Maclaurin series that we derived to solve for the series of some function, right? To get the power series of some function. So the Maclaurin series generally is given as f of x equal to, we have f of 0 plus f of 0, that is f prime of 0 x. You can say all over 1 factorial if you want, but 1 factorial is still 1. But let me just write it 1 factorial. Here you can call it 0 factorial. But because 1 factorial and 0 factorial, they will give you 1. So therefore, we don't have any need for it. Then plus this prime 0 all over 2 factorial plus f prime of 0 all over 3 factorial. Here will be x square and x cube. Then plus f vi, that's prime, that is into 4 places, of 0, that's the 4th derivative, all over 4 factorial x raised to the power 4 plus f of the 5th of 0 all over 5 factorial. We can still go on to get plus f the 6th derivative of 0 all over 6 factorial. Take note that this will be x raised to the power 5 and this will be x raised to the power 6 plus they will have the 7th of 0, is that 7th derivative all over 7 factorial, and it will keep on going. So this is what you need to know. The derivation that we derived this thing in our last class. We derived this thing, but that derivation is not that much important except you want to use it, maybe they ask you for it, of which they rarely ask for it, you understand? So but I just thought to show that you know, you understand that it is not a rocket science, so gotten for somewhere. So but if you understand the pattern in which Maclaurin series follows, you should be able to get this from your head, right? 0 factorial. Here is the first derivative, which is like 1 all over 1 factorial. Are you getting it? It keeps going that way. The power of x also starts from 0 to increase. 1, 2, 3, 4, 5, 6, and 7. You can get 8, 9, 10, and keep going, right? So now, in our own case now, we want to find I. Are you getting me? So this is the Maclaurin series. Let me write it here, Maclaurin series. So we have for I now have sine x. So we want to know the series of sine x, right? So how to know it is first we will find f of 0, right? So what is f of 0? For us to know f of 0, we need f of x, abi? So that's f of x, that's if you differentiate the f of x now is this guy, right? So we know that since this is our function, it means that the f of x, which is this f of x in our own case, are you getting it? Is now equal to sine x. Do you understand? I believe you should. So now, if we are now looking for f of 0, it means you should put 0 for where x is, abi? If you put 0 here, we'll get what? 0. Right? Now, for us to get the next derivative, which is f prime of 0, we need f prime of x, right? We need f prime of x, right? So what is f prime of x? Cos x. So cos x. So it means that this will be prime of what? 0, abi? So in that case, we put 0 for here, abi? 0, which will give you what? 1. Okay, so for us to get f prime prime of 0, we need f prime prime of x first, right? So now what is f prime prime of x? Since this will give you minus sine abi, which is equal to what? Minus 0, and which is still 0. But let me write it down step by step. So prime prime of 0 will give you what? Minus sine 0, which is 0. Abi? Okay. Now, what about f prime 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 of 0? Let's not waste time. You understand? Because I don't want the video to be too long. It will give you, this one, like the differentiate, it will give you cos x. Because of the minus, now minus cos x. Abi? Then if you put 0, it will be minus 1. So which is minus cos 0, which will give you minus 1. Then if you go for the IV, that's the fourth derivative with respect to, or with respect to 0 now, because we are substituting 0 for x. It will give you what? You know we are here, right? Which will give you minus, God bless you, sine x, which in our case is 0, Abi, which will now give you what? C0, right? Then if you now go for the fifth of with respect to 0, what will you have? You know this is sine, not minus sine because of the hands. To give you cos 0, Abi, which will give you what? 1. Then if you go for the sixth, for the what? Sixth, what will it give you? It will give you sine, Abi? No, minus sine now. Minus sine 0, which will give you what? 0. Then if you go for the seventh, in terms of 0, what will you get? You get minus cos, Abi? 0, which will give you what? Minus, right? Are we through? Okay. So now, substitute back into this place. We've gotten the Maclaurin series. So we'll substitute back into this equation. Because in our own case now, this f of x is now what? The sine x that we're talking about. So it means that the Maclaurin series for sine x will give you this guy f of 0. What is our f of 0? 0. Abi? Please be calling these values for me. We have already gotten it here. Then f prime of 0 is what? X all over 1 factorial. Hope you know. Plus f prime prime of 0 all over 2. What will that one give us? That's plus 0 all over 2 factorial x square plus what next? Prime. Give you minus 1. So minus multiplied by plus to the minus now be what to the domicile. That is minus 1 x raised to power 3, which will still give you x raised to power 3, because minus 1, that minus will bring minus here. 1 multiplied by x raised to power 3 is still x raised to power 3 all over 3 factorial, right? Then what will be here? This guy IV, are we here? Will give you what? Plus 0 all over 4 factorial x to the power of 4. Then what about this guy? The fifth one. Let's see the answer. What is the answer? The fifth one. So 1, which is x to the power of 5 all over what? 5 factorial. Then we have the sixth one, which is C0 plus 0 all over what? All over 6 factorial x to the power of 6. Here should be x to the power of 5, right? X to the power of 4. So then the seventh one now will be plus. Seventh one is minus 1. So if you multiply it, it will still give you x to the power of 7 all over 7 factorial, and it keeps on going. So I put minus 1 here, minus 1. So minus 1 will turn this place to be minus. Then x raised to the power 7, since I omitted it here, sorry for that. Right? So it means this is the power series of sine, but we can foil it. We can what? So this is 0, this will give you 0, this will give you 0, this will give you 0, right? So it means that the simple or simplified format is now x because 1 factorial is still 1, so it's not necessary actually to write it that way. Plus, okay, plus, this is 0 already, so this is the minus that will take over. Minus x to the power of 3 all over 3 factorial. This is 0, right? Then plus x to the power of 5 all over 5 factorial x to the okay, yeah, all over 5. Okay, there's no need of writing this already because we already have the x's we are fighting. Then minus x to the power of 7 all over 7 factorial, and it keeps on going. So this is the power series. This is the power series for what? For sine. The power series for what? For sine. What will be the power series for cos? Cos. So the power series for cos, you can easily do that one and post it in the comment section for us to see, because it will be similar to that of sine, only that all the odd numbers will be removed. All the odd numbers will be removed, just the even number. So it's still the same process. We keep differentiating, adding, differentiating and adding. But let us see another one for, let's do for, okay, since we did for sine and we left cos, so this cos is to be posted on the comment section. So let us do for Cosh now and leave shine for you to do. So for Cosh, so Cosh x, and we're looking for the power series. It means that f of x in our own case this time around is the Cosh x, right? So it means that Cosh, because f of the first, what we're supposed to find is what? F of 0. F of 0, that's what we're supposed to find. So it means Cosh 0. So what is Cosh 0? Cos 0 is 1. That is what we will get. Then if we look for f prime of 0, f prime of 0 now will now become shine. It will become shine 0, which will give you 0. F prime of 0 in this case will now become Cosh again 0, which will give you 1, because the difference between hyperbolic, these are hyperbolic functions. The difference between them and their corresponding normative function is that they don't have negative. Like if you differentiate cos, you're supposed to get minus sign, but in hyperbolic, if you differentiate Cosh, you will get shine. So there won't be any minus at the back. So that's just the difference between them. And also if you take cos 1, cos 0, you get 1. But if you take sine 0, you get 0. So it's still similar in some sorts. So have f prime of 0 should give you shine 0, which is 0, and f iv of 0 should give you Cosh 0, which is 1, and it will keep alternating that way. V will give you shine 0, which is 0, and we have this Vi of 0, which will give you Cosh 0, which is 1. So Vii of this will give you shine 0, which is 0. So you discover that what will happen, it will be similar to this one. It will be similar to this one. The only thing that will happen is that all the even numbers for this Cosh is what will be left, but the odd numbers will be eliminated. Let's see how it works. We'll have our f of x here now to become the one we're looking for, which is Cosh x, and it's now be equal to, here is f of 0. What's our f of 0? F of 0 is 1, so it will be 1 all over 0 factorial, which is C1, plus this guy. What will it give you? it will give you, let's see, 0. So 0x all over what? 1 factorial plus. This one will give you 1. 1 times x squared is still x squared all over 2 factorial plus. This one will give you 0 all over 3 factorial x cubed plus. This one will give you 1 multiplied by x raised to the power 4, which is x to the power 4 all over 4 factorial plus, right, which is 0 all over 5 factorial multiplied by x to the power of what? 5 plus. I omitted those ones, but you should also know them. Is f prime of f vi, that is this guy, 1, which is 1 times x to the power of 6 this time around. So it will be x to the power of 6 all over 6 factorial. X to the power of 6 all over 6 factorial. 7 will also go to 0. That's 0 x to the power of 7 all over 7 factorial. That is what you have. And it will keep going. So it means all the zeros will go, just as you said, all the odd numbers, all the odd numbers, all the what? The odd numbers will go out. So when they go out, you have Cosh of x being equal to 1, to start from 1, plus x to the power of 2 all over 2 factorial plus x to the power of what? 4 all over 4 factorial plus x to the power of 6 all over 6 factorial. So can you guess the next? The next will be what? The next guy. Guess. Plus x to the power what? 8 all over what? 8 factorial. So one thing about it is that there is a correlation. There is a what? There is something like you can guess the next one. There is a sequence. There is a pattern it follows. A pattern. So you can use it to know the next. We can also get for exponential. I might do for exponential inverse, then leave you to do the rest. Leave you to do the rest. Let's do for exponential. For exponential, it will be very, very simple for you to do because, okay, let me do exponential and leave exponential inverse. So this guy should be in the comments, and this guy should also be in the comments. So post it in the comments section after we're solving. Then we'll do this and this here. So let's see. So f of x, if our f of x this time around is exponential of what? Of x. If it's what? Exponential of x. What do we have? What will we what? Have. First value we need is f of 0. What is f of 0? Exponential what? 0. Which will give us what? 1. Beautiful. 1. Right? If you differentiate, if you what? Differentiate and you impute 0, what will you have? You still have exponential x, which you still give you what? You put 0 here. You still have 1. Are you getting it? If you differentiate the next time, what will you still have? Exponential what? Which will give you what? Are you there? So now we have the next one, the third one, differentiate, you still have the same thing. The reason is that the more you differentiate exponential, so long as I repeat, so long as there is no other value here in the power of the exponential apart from x, it will keep giving you exponential x. The only time you have something different when differentiating exponential is when it is no longer just only x. So maybe it's x squared, or maybe it is 2x, or maybe something x. But once it's only x, it will keep giving you what? Exponential x. Don't worry, I'll post a video on pure differentiation so that you will know what and what to expect when differentiating different functions. So exponential derivative is first differentiate what is on the power side, what you get, write it down, then write the whole thing, multiply it by that. You understand? So now if you have x here, if you differentiate x, you still get 1. Multiply it by exponential x that way, it will give you exponential x. Keep repeating it, you still keep getting the same thing. You understand? So it will keep giving you the same thing. So all of them, let me just write all of them, v of 0, both id of 0, d of 0, vi of 0, and dii of 0, all of them, everything will give you what? 1. So if everything gives you 1, what will happen? The only thing that will happen in this case is that you will have something like this. You have something of this nature. You have something of this nature. And what will you have? You will have f of x now, which in our own case is exponential x, will now be equal to f of 0. Our f of 0, remember it was what? 1 all over 0 factorial. 0 factorial is 1. So it will give you 1 over 1, which is 1, plus f prime of 0. F prime of 0 is still what? 1. So it will be x all over 1 factorial, which is still 1. So no need, which is still x. So no need. So plus, here now, prime will give you what? 1. So it will give you 1 multiplied by x squared, which is still x squared all over 2 factorial, plus x cubed all over 3 factorial, because it's still 1, plus x to the power of 4 all over 4 factorial, plus we have x to the power of 5 all over 5 factorial, plus x to the power of 6 all over 6 factorial, plus x to the power of 7 all over 7 factorial, and it keeps going. So if you check it, you discover that this one now does not, exponential does not eliminate any number, whether even or odd. It does not eliminate. So the only thing is that it starts from the 1. Are you getting me? It starts from the 1 and it keeps going x. So the, just like saying power of x here is 0, power of x here is 1, power of x here is 2, but it will keep dividing by the, corresponding by the corresponding factorial. So it will keep going that way and going that way till infinity, right? So that is that for that. All this is the expanded form of the power series for this exponential. I can condense it. I can what? I can condense it. So when you condense it, you have something different, like it will become smaller. But before condensing, let us finish up with this guy. Well, let us finish up with this guy. Of x, f of x equals ln 1 plus x. Ln 1 plus what? X. Ln 1 plus x. So the first guy I need is f of 0. So f of 0 now will now become ln 1 plus 0, which will be ln 1. And ln 1 should probably give us 0. So now if we take f prime of x, what will it give you? So differentiating this guy. If you differentiate ln, that's another thing you need to know. You need to know the derivative of ln. To differentiate ln, for you to differentiate ln, differentiate what is here first. You will get 1. Differentiate what is in the bracket, you get 1 all over. Then write down what is in the brackets. Forget about the ln. So you now have 1 plus x. That's why when you differentiate the x, you get 1 over x, because you differentiate the x, you get 1 all over, you write the x back in the denominator. That's how you have differentiated it. So now we have this. So if you input 0, it's now become f prime of 0, which will give you 1 all over. Here we should have 0, abi. So 1 over 1, which will give you what? 1. So if you differentiate again, yet again, you should have this. You are differentiating this. So this is like saying, this guy is like writing it this way. Let me shorten it and have, it should be 1 plus x inverse. That's what it means, right? 1 plus x inverse, because of anything 1 all over something means inverse of that same thing. So if you differentiate this guy, now what you have is the minus will come forward, abi? That's chain rule differentiation, chain rule, that's what we call it. Chain rule, anything that has power, bracket that has power. Chain rule differentiation, the shortcut for it, write down the power, multiply by, differentiate the term in the brackets. That's everything here. Differentiate it. What you get is what? Is 1. Because if you differentiate 1, you get 0. Differentiate x, you get 1. Multiply by, rewrite everything in the bracket. That's 1 plus x. Then that power that was there, minus 1 from it. Minus what? 1 from it. Minus 1 from it. So you should have minus 1 times 1 is C1. So because it's in the front of bracket, no need of writing the 1. You just write this, open bracket, plus x, 1 plus x to the power of minus 2. Minus 1 minus 1 will give you minus 2. So this is what you have. So if you impute 0, if you what? Impute 0, you should have minus 1 plus 0 minus 2, right? Which will give you minus 1, this should give you 1. So it will be open bracket 1 to the power of minus 2. 1 to the power of minus 2, which will give you 1 all over 1 to the power of 2. Everything multiplied by minus 1 or minus. So which will give you 1 all over 1, because 1 divided by 1 raised by 2 is still what? 1. Then multiplied by this minus, you have minus 1. So everything ends up with what? Minus 1. Minus 1. So doing for the next derivative, we have prime of x first, so that we know what it is. So we are differentiating this guy this time around. We are differentiating this guy. So if you differentiate it, the same thing, the power here comes here. So it now become minus 1, because you know 1 was here, just that I didn't make it visible. Minus 1 multiplied by the power minus 2, then differentiate the term in the bracket, which will still give you multiply by 1, will give you 1, multiply it, then multiply by, write everything in the bracket again, then remove 1 from the power, that power. So you have this times this will give you 2 times 1, 2. So 2 to the bracket of 1 plus x minus 3 this time around. Right? So when we substitute 0 into it, we will have 2 into 1 plus 0 to the power of 3, which will give you 2 multiplied by 1 all over 1 to the power of 3. That's what it means. This will, everything here will give you 1. Multiplied by this 2, you still get what? 2. So let's take for the fourth one, prime of x. I think this will be the last one, so that the video don't become too long. But the process keep continues. Continues. The process continues. So we have differentiating here. You multiply this by this. You have minus 6. Then differentiate the term in the bracket. You have 1. Then rewrite everything. Multiply by rewriting everything. 1 plus x. Then remove 1 from the power, which will give you minus 4. That's minus 3 minus 1, minus 4. So we have minus 6 into 1 plus x, all to the power of minus 4. So we should have, if you put 1 here, so be 1, okay, if you put 0, sorry, that's f prime of 0. If you put 0 here, you should have 6 minus 6 open bracket. Here will end up being 1, because if you take the power of this, that is this about minus 4, you will still get 1, because it will be 1 all over 1 to the power of 4, which will give you 1 all over 1, which is 1. Multiplied by this minus 6, you get minus 6 as your final answer. If you are not sure of what we are doing here, because it's the application of laws of indices, you can just press this in your calculator. But here, let's here be 0. That's minus 6 open bracket 1 plus 0 close bracket raised to power minus 4. Your calculator should tell you this to prove that what you are doing is correct. So now if you impute values, because I don't want to do for the rest. You can do for the rest. You can do more. That's IV. If you differentiate this guy this time around, where is he? Yeah, this guy. That's minus 4 will come down. That's minus 24. No, plus 24. then remove 1 from the power and the rest of it. So you can just get more, but let's just stop here. It seems to be short anyway, but for the sake of time, let us have this as ln 1 plus x being equal to prime of 0, no 0 first, f of 0 to give us 0, then prime give us 1. So it will be plus 1 times x is still x all over 1 factorial, which will still give you x. Then prime of prime. What the prime give us? Minus 1. Give us minus 1. So it will be minus 1 times x to the power of 2 is x to the power of 2 all over 2 factorial. Then plus
f prime will have, okay, this is supposed to be IV. This is supposed to be IV. Then this guy IV also. So this is prime, which is what 2. So this is supposed to be what? Plus, and we have prime. Okay, prime, this is supposed to be 2 x to the power of 3 all over 3 factorial. Then the next one, which is the fourth one, we are telling the fourth one only that we didn't, denote it. We are still letters of this. So we should now give plus, and plus, what are we now having? We are now having minus 6, which we will turn it back to minus 6 x to the power of 4 all over 4 factorial. And if we go now, we have 0. This is the 0. It does not matter. We have x minus x to the power of 2 factorial is the same as 2 times 1, which is 2. Then this one is still the same thing as saying 2 x to the power of 3 all over 3 times 2 times 1, which is 3 times 2. 2 cancel 2, then minus 6 x to the power of 4 all over this times 3 times 2 times 1, which is still 4 times 3 times 2. 3 times 2 is 6, cancel this 6, and it keeps going. So we have finally x minus 2 squared all over 2 plus x raised to the power 3 all over 3 minus x raised to the power 4 all over 4. So you observe that this one is still a coincidence with other series like sine and the rest of it. Okay, like exponential, that's exponential minus x. But the only difference is that the numerator does not have any factorial.
Writing condensed form. So we have the condensed form will now become 4 e to the power of x. You should have sigma n from 0 to infinity. That is what you have of x to the power of n all over n factorial. That is what you have for this guy. If it is exponential of minus x, the only difference that this will carry is that here we'll be carrying minus 1 to the power of n. That's just the difference. But you can check it out. This is for minus x. This is the only difference. If I clean this, it becomes exponential. If I put this thing back, that's minus 1 all to the power of n. If you put it, it becomes for minus exponential minus x. But if you leave it like this, it becomes for exponential x. So now let's move over to sine x. Sine x. What will sine x give you? Sine x should give you sigma n from 0 to infinity of minus 1 all to the power of n, x to the power of 2n. No, yeah, should it be 2n? I think yeah, it will be 2n all over 2n factorial. That is what it will be. 2n factorial. 2n factorial. Then we should have for cos. For cos, okay, I think this is for cos. This should be for cos x. Then for sine x, sine x should be from 0 to infinity of minus 1 to the power of n x n x 2n plus 1 all over 2n plus 1 factorial. Yes, this is for sine. So there are other ones. There are other condensed formats. There are other condensed formats. Let's see. I think ln 1 plus x is exponential as it starts from 1. This one starts from 1 because 0 will not give you anything. To infinity of 1, that is minus 1 to the power of n plus 1 x raised to the power n all over n, no factorial. So these are the condensed formats for each of these. So we'll stop here for now. In our next video, we'll continue with how all these things are applied in solving series solution of differential equation. So you see why we are learning all these things. Why are we learning all these things? If you are solving a series of differential equation and you are ending up with something like this, like you didn't get this, you are getting something like this. You have x minus x to the power of 2 over 2 factorial minus this. Your brain should tell you that I've seen something like this before. So therefore the answer should be, since it is this, and this guy is the series expansion for what? For ln 1 plus x. It means that answer you got is ln 1 plus x. So you can just use the approximation to know what it is pointing at. So thank you for watching and see you in my next video.